guys, my name is Craig and welcome to Payment Solutions. In today's video, we're going to talk about the Pascal's triangle. But before we start, please make sure that if you're new to my channel, you subscribe and hit the notification bell so that you don't miss out on any new videos. So to start off, you should be able to expand, right, solving for these brackets, and as well you should be able to solve for indices, right? So of course for the first one, if you're to expand, we say 2x minus 5 times 2x minus 5, like this, and we get 4x squared minus 20x and plus 25. So like I'm saying as well, you should be able to solve for indices. So this, we're saying 3 to the power 5, right, multiplied by x squared raised to the power 5, like this. And from this, we can get 3 to the power 5, that's 243. So this is 243, 243x to the power of 10. All right. So basically, you should be able to expand for these. Now allow me to erase this. Okay, so the Pascal's triangle, it helps us come up with the coefficients, because we can't really expand the normal way, something like 2 plus 3x to the power 4. It will take a bit of time. So the Pascal's triangle is there to assist us with the coefficients, such that once we've got the coefficients, then it will be easy to expand. So now I shall show you how we come up with the Pascal's triangle. So for the Pascal's triangle, basically, let's say we've got a 10a plus b raised to the power of n, right? So since we're just concerned mainly about the coefficients, we start by writing down the ones, right? So we write down the ones, and the number of ones that I'm going to write are determined by the power n. So in this situation, let's just say we're going to put 6 ones. So we put the ones in a decreasing manner like this. So that's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So you've done it this side, and as well you do it this side. 1, 2, 3, 4, 5, 6. Right. So the Pascal's triangle is one of the ways in which we can expand binomial expressions. And by binomial, we are saying we just have 2 terms inside the bracket. So as you can see, I've started off by putting 2 ones here. So we put 6 ones, 6 ones. And I said we're putting 6 ones because we're just assuming that the power there will be to the power of 6. So now we need to fill in for these gaps here, right? So we start off for the first year, we've got 1, 1, right? So we add, to get the number that has to be here, we add the 2 numbers that are between, right? So we're saying we've got a 2 here. Then if we say 1 plus 2, we get a 3. 1 plus 2 plus 1, we get a 3. 1 plus 3, we get a 4. 3 plus 3, we get a 6. 3 plus 1, we get a 4. 1 plus 4, we get a 5. 4 plus 6, we get a 10. 6 plus 4, we get a 10. 4 plus 1, we get a 5. 1 plus 5, we get a 6. 5 plus 10, we get a 15. 10 plus 10, we get a 20. And then 10 plus 5, we get a 15. And 5 plus 1, we get a 6. Right? So these will be the coefficients. So now let's say we needed to expand something like, say, a plus b raised to the power 4. So raised to the power 4, we're saying 1, 2, 3, 4. The power 4, these are the coefficients that we want, right? So we're saying we've got a, right? 1 times a to the power 4, and b will be to the power of 0. Then plus 4, right? A to the power of 3, b to the power of 1, plus 6, a to the power of 2, b to the power of 2. Then plus 4, a to the power of 1, b to the power of 3. Then plus 1, a to the power of 0, b to the power of 4. So as you can see, right, as we move from the left to the right, the powers of a are decreasing by 1, and the powers of b are increasing by 1, right? So now, of course, if we simplify this, we get a to the power 4 plus 4a to the power 3b plus 6a squared b squared and plus 4a b to the power 3 plus b to the power 4. So this is how we use the binomial expansion. The Pascal's triangle. So this is what we call the Pascal's triangle. Right, now I would like to attend these questions. The first one says use Pascal's triangle to expand. For number A, for part A, we need to expand 2 plus 3x raised to the power 4. So raised to the power 4 as well, these are the coefficients that we want. So we shall say 1 times 2 to the power of 4, 3x to the power of 0, right? And then plus, right, 4, so I'm saying 4 times 2 to the power of 3, 3x, okay, so this is 3x to the power of 0 like that, 3x to the power of 1, then plus 6, so we now have a 6, 2 to the power of 2, and 3x to the power of 2 as well, and then plus a 4, so I'm saying 4, 2 to the power of 1, 3x to the power of 3, and then plus a 1. 1 times 2 to the power of 0, 3x to the power of 4, right? And now we can further simplify those two. 2 to the power of 4, we get a 16, then that's a 0, that's a 1, that's a 1. So here we're saying 16 plus 2 to the power of 3, that's 8. 8 times 4 times 3, that's 8 times 12, which is 96. So we get 96 multiplied by x here, and then plus, right, 3x to the power of 2, that's 9x squared. 9x squared times 4 times 6, that's 9 times 24, to give us 216. So I'm saying 216x squared, 216x squared plus, right, 3x to the power of 3, that's 27x to the power of 3. So 27 times 2 times 4, we get 216 as well. So this will give us 216 x to the power of 3, then plus, right, here we know 2 to the power of 0, that's a 1. So 1 times 1 multiplied by 3x to the power of 4, that's 81x to the power of 4. So 81x to the power of 4, like this. So this is the result that we get for the first. And now moving on to the second. The second says 2x plus 1 to the power of 6. So now to the power of 6, it means we need these coefficients. 1, 2, 3, 4, 5, 6. So we're saying 2x plus 1 raised to the power of 6 is equal to, this is 1 multiplied by 2x to the power of 6, 1 to the power of 0, plus 6, right? 6 times 2x to the power of 5, 1 to the power of 1, plus 15, 2x, so this is 15, yeah, 15, 2x to the power of 4 times 1 to the power of 2, which is just 1, plus 20, 2x to the power of 3 times x to the power of 1, 2, 3, but it's just 1, and then plus 15, 2x to the power of 2 plus 6, so there's a 6 here, so plus 6, 2x to the power of 1, and then plus 2x to the power of 0, so plus 1 times 2x to the power of 0, right, times a 1, which is just a 1. So now simplifying this, 2 to the power of 6, 2x to the power of 6, that will give us 64. So 64x to the power of 6, right, plus 2 to the power of 5, 2x to the power of 5, that's 32x to the power of 5, 32 times 6, that will give us 192. So plus 192x to the power of 5, and then plus 2x to to the power of 4, that's 16x to the power of 4. 16 times 15, 16 times 15, that's 240. So we're saying plus 240x to the power of 4, and then plus 2x to the power of 3, that's 8x to the power of 3, times 20, we get 160x to the power of 3, and then plus 15 times 4x squared, you get 60x squared, and then plus this, you get a 12x, and then plus 1. So this would be the expansion for part B. Now moving on to part C. For part C, allow me to create space here. So I shall erase this. Okay, so for part C, we're saying that put this here. For part C, we need to expand 1 minus 4h to the power of 5. So to the power of 5, we need these coefficients here. We need these. So 1 minus 4x raised to the power of 5. We are saying that we've got 1 multiplied by a 1. Right, 1 multiplied by a 1 to the power of 5, and a minus 4x to the power of 0. So as we can see that here we've got a 1 and here we've got a 1. So since we have 1 here, we're just considering the coefficient. So plus 6 times 1 to the power of 4, and then times minus 4x to the power of 1. Plus, I'm sorry, this is supposed to be 5, because for to the power of 5, we need these coefficients. And then plus 10 times 1 to the power of 3, then times minus 4x to the power of 2, plus 10 times minus 4x to the power of 3, and then plus 5 times minus 4x to the power of 4, and then plus 1. So this is now plus 1 times minus 4x to the power of 5. So now we shall simply expand. Then here we know we get a 1. And then, so this gives us a 1 here. Alright, got a 1 there. 1 here. And here we get what? We get minus 20x. Then here, minus 4x squared, we get 16x squared. Times 10, that's plus 160x squared, and then minus 4x to the power of 3, that gives us minus 64x to the power of 3, times a 10, that will give us minus 640x to the power of 3, and then minus 4x to the power of 4, we now get what? Let's see, to the power of 4, that's 256. And then times 5, that will give us 1280. So plus 1280 x to the power of 4, and then minus, right? Well, now this automatically minus, because since you have a negative and you're raising this to the power of an odd number, then we need a negative here. 4 to the power of 5, that will be 1024. Okay, yeah, so minus 1024 x to the power of 5. So this will be the expansion for part C. And now allow me to erase. Okay, let me just continue. So for number two says write down the first 3 terms in the expansion of 2 minus 10x raised to the power of 5 in ascending powers of x. So in ascending powers, it means you're moving from x to the power of 0, x to the power of 1, x to the power of 2, and so forth. Right. So this is x to the power of 5, and the coefficients that we need are here. But since we are only concerned about the first 3 terms, we shall consider these coefficients. Right. So for those coefficients, we're saying that 2 minus 10x raised to the power of 5 would be equal to 1 times 2 to the power of 5 minus 10x to the power of 0 plus 5 times 2 to the power of 4 minus 10x to the power of 1, and then plus 10 times 2 to the power of 3 minus 10x squared. And now we shall simplify this. So simplifying this, here we get a 1, and then that will be 32. So there's 32, and then 2 to the power of 4, we get a 16. And 16 times 5, we get 80. Right, 16 times 5, we get 80. 80 times minus 10, we get minus 800x. Right, and then 2 to the power of 3, we get an 8. 8 times 100, that's 800. 800 times 10, we get 8,000 x squared. So this is the result that is required for number 2. Then now for number 3. Number 3 says use Pascal's triangle to find the value of 1.03 raised to the power of 4. So that being raised to the power of 4, definitely we need to rewrite it in such a way that we've got a binomial expression. So we can rewrite this as 1 plus 3 over 100 raised to the power of 4. And now since it's raised to the power of 4, we need these coefficients, yeah? So we are saying that we've got, this is now for number 3. So for number 3, we're saying we've got 1 plus 3 over 100 raised to the power of 4 being equal to 1 times 1 to the power of 4, 3 over 100 raised to the power of 0, plus 4 times 1 to the power of 3, 3 over 100 raised to the power of 1, and then plus 6 times 1 squared, 3 over 100 raised to the power of 2, right, and then plus 4 times 1, which is just 1 to the power of 3, which is just 4, times 3 over 100 raised to the power of 3, and then plus 1 times 3 over 100 raised to the power of 4. Like this. So now we shall simplify that, and this definitely gives us a 1. So we're saying 1 plus 4 times 3 over 100, right? And then we're saying plus 6 times 3 over 100 squared, 3 over 100 squared, and then plus 4 times 3 over 100 raised to the power of 3, right? And then plus 3 over 100 raised to the power of 4, right? So we get a value of 4.125, right? 4.125, 4.125. In actual fact, 4.126, and this is to 4 decimal places, 4 significant figures. So to 4 significant figures, this is the answer that we get. Okay, so this was looking at the Pascal's triangle and how we would apply it when we're asked to expand. And please, so this marks the end of this video. Please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.